Now here's a bit of an experiment. This is an MLI engine which was built sometime around the 60s, early 70s, and these were supplied to school laboratories for energy transfer experiments. The engine itself can be connected to a whole range of different output sources, such as a turbine, a pulley system, a dynamo, two different size dynamos, and a number of other sort of flywheels and things to expound the virtues of physics to the youngsters who are being taught. The engine itself is a Stuart Turner ST1, very old design of engine dating back to the 20s. The boiler is Stuart, which is a copper vessel with quite a generous superheating element, as well as a extra pair of heating tubes. I'm currently using a Mammold SE3 burner for this one because these engines were designed to be gas powered and connected to these school Bunsen burner gas jets. You can see that the engine is controlled via a small little stopcock there. It's connected to the dynamo via a piece of flexible wire loop material, a bit like you find on curtains, holding up net curtains and so on. This is the dynamo. It's a Johnson 660, which is quite large. I mean, they were used in a lot of battery-powered toys in the 1970s. Because of the different height between the two items on these plinths, I've jacked this one up using some Meccano strips to give it a little bit more of a straight connection here, because I found on a previous run that the actual unit here, the dynamo, dropping down did place some extra resistance on the two couplings. I've got this connected by a couple of wires. It's going to be connected by a couple of wires to this old GPO Postman's lamp, of which I've inserted a Miller 6-volt dynamo bulb, which I've tested, because this is meant to be a 6-volt output from these 4mm jacks that you can see on the back of it. You can see the whole thing is mounted on these very, very substantial metal bases, which are quite solid. The engine itself, as well as the dynamo or any other accessory, can be unscrewed using these Bakelite type screw bolts, and then slided back and forth to make the necessary adjustments. The engine itself I've given a clean and a thorough lubrication, because I tended to find on the first run this one did need a lot more lubrication to actually run successfully. This particular engine itself has been slightly modified in as much as that the aluminium boiler cowl has been jacked up on these extra spacers to accommodate this gas jet burner, which you can see it's quite a hefty affair, and I haven't had a chance to really test that with a gas supply at the moment, so as yet I'm running it on METHs, which it ran very well. These particular engines also have a safety valve, which is there, which essentially has a phosphor bronze ball in it, which is held in with a spring and allows excess pressure to escape. Some of them have been changed in the past to a metal ball, a ball bearing, which essentially then has over time rusted in, and there is, I think there has been documentation of a boiler explosion because of the safety valve not functioning. There's no other connections on the boiler apart from the heating or the steam heated boiler pipe, which comes out from here. So there's no sight glass, no overflow plug. Obviously the Stuart S. Turner ST is a oscillating type cylinder, so you can see there is an extra sort of safety valve device there. I have to say it's a very well made machine little engine, and it does go extremely well. I'm hoping on this run now that it'll run a lot smoother and we can generate maybe enough current to light the lamp in this affair. Which what I've done is, if you see inside, I've earthed one wire to the actual casing, and the other one I'm holding it against the actual terminal on the back of the bulb using some sort of Meccano, and I've used some generous amounts of black insulating tape to ensure that nothing shorts the circuit. So there you have it. It's an MLI school steam engine, which I believe we're in direct competition with Griffin and George for the supply of steam engines for these type of experiments. Apparently it does predate the Griffin and George engine. Curiously, this was finished in a silver hammerite sort of type finish, whereas the Malins ones tended to use green hammerite finish around about the late 60s into possibly the early 70s. So without too much more chat, I'm just about to get this prepared now, lubricated, get the boiler charged up with some boiling water and get some meths into that lamp, and we'll see if this can generate any electricity, even maybe to get a glimmer on that bulb. It's a 6-volt bulb burner at the moment. I've taken the little 3-volt bulb out, so if it doesn't work, it puts too much draw on the dynamo and the engine itself, I might ultimately change it for 3-volt, and we'll give it a try from there. So let's see what happens.